Okay, guys, sorry, I forgot to start it. We're already on number 3, but the first 2 are pretty easy. You can ask your comrades about that before test time. Yes.
Is that the type of
Yes.
thing you want, not the limit one? Just like put as if like
Fill in the blanks. It's a different way of expressing a limit, but that's the way that it's written on here. You have to know how to handle it. That's why I wrote it. Is everybody okay with number 2? Yes. Question? Okay. Anybody? Any questions? Sarah or Sam, any questions? They're both scrambling for their microphones. Oh.
No, thank you.
Okay. All righty, number 3. I'm going to change the name, but it says something like this. I'll change it to Ashton. The population of Ashton begins like that. Oh no, I'm going to make it Idaho City because that's in my area, and this actually happened to them. The population of Idaho City was 20,000 in 1890. And it has been decreasing at a rate of 0.97% per year. Got all that? 20,000 in 1890. That's when the silver mining rush hit over there on the west side of Idaho. Okay, so a lot of people there. 20,000, and it's been decreasing at a rate of 0.97% per year. We are to do 2 things. Estimate the population in 1930 and estimate when the population reached 10,000. Everybody know the equation for this? Population as a function of time is equal to, anyone?
20,000.
Good.
We go the 1 minus what your number was. I think it was like I forgot what it was.
It was 0.97%.
It'd be 0.0097.
Very good. Don't understand why that's 0.00? Raised to the t. That's what you're going to use. I don't expect to see that anywhere. This is your tool that you got to build yourself. So it says estimate the population in 1930. What are you trying to find? P of 40. Because it was in 1890 that it was 20,000. That's 40 years later, 1930. You follow that? See how it's working out? And you figure this out. Probably you will figure this out in your calculator, but you can leave it like this. It doesn't care. It handles things nicely this way as well. And you just crank that out. Round to the nearest whole person, please. Talking people here. That's A.
Going to be 13,543.
Okay. 13,543. Okay. Round it to the nearest whole person, or at least round to a whole person. I don't care if it's the nearest one. Just so long as you're in the general range, but you don't put decimals on stuff like this. Then estimate when the population will reach 10,000 or did reach 10,000. How do you do that?
By the 20,000 over and log.
You could certainly do that. You could also graph it, remember? If you get your y values up a little past 10,000, you'll be able to see that line come through and hit this function. And that will tell you when, if you look at the x's. You could also solve it. It would be 10,000 equals 20,000 times 1 minus 0.0097 to the t, and you're looking for t. So you take 10,000 divided by 20,000. And that equals this, and then you log. I would natural log that, and I would go t natural log of this. then divide, that'll do it too. You can do it algebraically. Here's the thing. If you do it in your calculator and you miss it all, because I can't see what you're doing. If you want to show me some work on this, or if you want to do the work and see if it matches your calculator, even better, that shows you're checking it. But do y'all understand the process, what I did? I put 10,000 out here for the population. I'm looking for T. Divide by 20,000. You log that. I mean, 10,000 divided by 20,000, that's a natural log of a half. And then you log this side as well over here after dividing by that. And you have T log of that. So you have to take the log of a half divided by the log of that decimal, and that will tell you T. But it will be T past 1890. You'll have to still give me the year. Since this one landed at 13,000 something in 1930, it's probably a little past that. 1940 something, I would imagine. So I don't know, I'm guessing. Maybe 50. Anybody figure this out? Or do it on the graph? 61?
Yeah.
Okay. It was probably pretty flat by then, so it wasn't dropping off too hard.
What was the question again for the second one?
When will when did the population reach 10,000? You understand this process here? The only reason I have my finger drawn through there is because I'd already divided by the 2,000. I just wanted to show you that's what I did over here. And this is what was left. So it was T natural log of that. And then it's T times that natural log. You got to divide by the natural log of that over here. And it'll tell you that T past 1890. Just don't forget to reconcile the year when you answer this question. It's not very hard, but don't forget you're giving me a year, not a number of years after. Is everybody clear on what's being asked and how to answer a question on this? Okay, if you want me to consider your work in case you miss it, you're gonna have to show me this kind of thing. If not, and you're sure your calculator is correct, and you've rounded to you've gotten the correct year, things are good. If you get the right answer, I'll give you full credit. Get the wrong answer, and I can't see why you get nothing. Okay, that's A and B of number 3 then. Number 4 says solve by changing the equation to logarithmic form. It even reminds you how to go about solving for this. And it's something like this. It says solve by changing the equation to logarithmic form. So it's telling you how to do it. And if you don't do it that way, and I can't see your work, you're going to miss something. Because it's telling you specifically how it wants you to do this, by changing it to a logarithm. How do you change that to a logarithm?
So we log and then 12 equals 5x.
Remember how to do that? If the log and the exponent have the same base. But then these two kind of guys, these guys right here kind of switch places as far as sides of the equation. It's the natural log. We're going to choose natural log because, well, because of the E, I guess. Because that has that same base as this. So it's natural log of 12 equals what your exponent is. That's how you isolate it. So what the answer is going to be is the natural log of 12 over 5. And I don't care if you write it like that. That's fine. But you can also give me a decimal approximation. Yes?
Isn't that the same thing as just putting a natural log at the beginning? So it's 5x equals natural log 12?
Sure. As long as you change it to a log, however you think about it, as long as it's a log in the next step, that's fine. Okay? I've taught you several ways to go about this, and so yeah, any of those are going to convert it, so that's fine. Everybody okay? Number 5 says, sketch the graph of. I expect a really good sketch because your calculator is doing it for you. So you better be able to do it with, I would plot a few points of accuracy on the grid. Here's the thing that just kills me. And I've told you this before. The grid very clearly on this, in this problem anyway, very clearly gives you a left side number, a right side number, a bottom number, and an upper number. For heaven's sake, design your window that way. so that your copy can be exact. So your copy can be just what's necessary and it's all there. And that's all it says. Sketch the graph up. And it's y equals some combination of a logarithm. But it's really easy to put in your calculator. And because it is, I expect a really accurate graph. So use the window they provide in the answer so that you can just copy it right from your screen to there. And I would get a couple of points on there by saying, second calc a value at 1, and then graph 3 or 4 of them. So you got something to connect and it's very accurate. You know what I'm saying? Okay. Number 6. Give the exponential regression equation for the data. So in number 6, they give you several points of data, several x's and several y's to go with them. And it says, give the exponential regression equation. That means when you go to regress it, after you get it plotted, get the points plotted, and you go to regress it in your calculator, make sure you choose exponential. And it says, then estimate the y value associated with x equals, and it gives you that. Gives you what you remember how to do that once you get the curve? You go second calc a value at x equals whatever they tell you. And it says round the answer to the nearest 0.01. Because this problem is done almost exclusively in your calculator, and I can't see very much, if you don't round it to the nearest hundredth like it said, it's going to cost you. So pay attention to the way the answer ought to be. And it does say to the nearest 0.01, which is the nearest hundredth. So pay attention to the rounding and make sure you do it properly. So it looks like this. Well, it says number 6 over on the right where you put the answers. It says equation colon, and it says value colon. Not very hard. People don't miss this one. Make sure you do an exponential regression. Okay, next one. People miss this one routinely. They don't very often miss very many points, but very few, I should say very few. A few people cannot remember how to do this exactly. Here's what it says. Use the properties of logarithms to write the expression, and it gives you an expression, as a sum, difference, or multiples of logarithms of x, y, or constants. In other words, expand the logarithm. All that verbiage and crap in there just says, here's a big old log. It's a log of a whole bunch of junk. Expand it. And I'll tell you the biggest mistake people make. I'll just give you a sample up here so that hopefully you won't make this mistake. If I ask you to do the log of the cube root of 5x squared y over z to the 7th. Actually, I'm going to take this off here because it kind of defeats the purpose. So I'm just going to say 5xy up there. These are all crammed together like this. And a lot of times they see the multiplication between here and here, but there's also one here. There should be a separate log for 5. It's not the log of 5x. Main thing when you expand stuff, folks, is at the back end of every logarithm, there better be one thing, and just one thing. Whether it's a number or a variable or whatever, there should be just one thing following each log. If it's an exponent, as in that 7 right there, that 7 should be out in front of the log, not the log of x to the 7th. Right? Now, what about that 1/3? That is what that 1/3 is. It seems to belong to everybody. So you may write it like this if you want. You can write, if I expanded this one, you can write the log of, or you can put, well, let's see. That would be the same thing as the cube root of 5, right? So you could put 1/3 out here, log 5, plus 1/3 log x, plus 1/3 log y, minus 7/3 log z. Does that make a sense?
Mhm.
Okay. Yes.
Is it possible if we just do a whole entire parentheses around it and put a 1/3 in the front?
Yep, that's
And
fine.
on the log z, we put a -7 log z.
Yep. That would work as well. As long as you understand the 1/3 belongs to everybody, one way or another. Okay? All right. Number 8. Now we're getting into the nitty gritty. Number 8 says, solve the equation algebraically. And because they told you to solve it algebraically, and a correct answer without the work won't get you, you'll get 1 point. That's it. When it says to solve it algebraically, I expect to see the algebra accompany it, something like this. I don't expect this to come out nice. I mean, the process will be the same, but let's say 14 minus 3 log x equals 26. First thing you gotta do,
14.
get rid of the 14, correct, so it'll be -3 log x, this is what you're gonna show me, you don't have to actually show me that you're gonna subtract 14, that's a little bit childish at this stage, but show me the result of doing it, which would be what? Well, then,
Can we divide by -3 or?
you
is that-
have to.
Okay.
You have to isolate the log before you can change it to an exponent. So you gotta divide by -3, so we have the log of x equals -4. Now, folks, you cannot log a negative, but when you do log something, it is possible to get a negative. So don't panic on this. Okay, so now we've got the log isolated, now what?
Oh, we have to raise it to 10, both sides?
We have to, well, yeah. We gotta take this 10 that's understood there, raise it to this power equals x. In other words, changing the log to an exponent.
Oh, yeah.
We're 10ing it. So it'll be 10 to the -4 equals x. And I expect the decimal form of this, which would be 1/10,000.
If our calculator just says it's 1e -4.
That means 10, it means 1 times 10 to the -4. That's what that means. And if you write that little e in there, it means you don't have a clue what you're looking at. So do not express this as 1e -4. All that means is you can copy an answer out of your calculator. It gives no indication that you understand what you've got. This is what you've got, and that's what I expect to see. Y'all clear on that? Okay, that's what I want to see. This is one step from reconciling that negative exponent. I want this. Okay? All right, there's the first 8. If this had been plus, by the way, then you would have answered 10,000. Yeah, okay. Guess I better take those back off. So that if somebody's reviewing this, they don't freak out, wonder where it all came from. I'll leave it like that. Okay. Next one says, this one nobody misses. If you know how to do it, nobody misses this. And you guys know how to do this. It says, how much greater was the amplitude of the ground motion in the 1990 Iran earthquake with a Richter of than the 1988 Armenia earthquake with a Richter of? Do you know how to do that?
Subtract them, and then that's.
You can, that will be the
Find the
power of 10.
difference.
Yeah, you can subtract the 2 and be the power of 10. What it really comes down to is this. If you've got one of them that is a 8.2, that's an exponent on 10. If the other one is a 6.9, then you would have 10 to the 6.9. Whenever you want to know how much greater something is than another, you take the big one divided by the small one.
Oh, then,
Because if you want to know how much greater, how many times older I am than you, you would take my age divided by yours. So it's the big one divided by the small one, which you said you just subtract those, but it's because when you're dividing things with the same base exponent, you subtract the exponents. That's why you can subtract. You don't have to, you can just figure this right exactly like it is, or you can write it as 10 to the, what would that be? 12 minus 9 is 3, 7 minus 1.3. You could figure that, that'd be great. That'd be the same thing as doing this division. However you do it, these Richter readings are exponents on 10.
So do you want it as a 10 to the 1.3 or as?
I want this. Rounded to, I don't know, 2 or 3 places. Okay, we ready? Are we okay on that one? Number 10 is the one that is the most intense for your work that you have to show. It says solve the equation algebraically, and it's one of those hyperbolic trig things that you're going, what? You never taught us that. I did. I referred to it as that, but then we did the algebra and it didn't involve any trigonometry at all. But it was one of those like this. something like this. I'll walk you through it if you want. Don't expect it to come out pretty. E to the x minus e to the negative x over 4 equals 5.5. You are to solve for x algebraically. It says right there, solve the equation algebraically. Do you know how to do this?
Mhm.
I'm going to walk you through it kind of fast because you're supposed to have experienced this on your exercises. So first thing I would do is multiply both sides by 4. Is that right? Okay. Then I would reconcile this e with its negative exponent. Then I would multiply through by e to the x. Then I would quadraticize it, realizing it is quadratic in form. And then recognize probably not going to be able to factor that. 1 and 22 is not going to work out. So I recognize I'm going to use the quadratic formula on that, and the quadratic variable is e to the x. It's equal to the opposite of b. Is that 441? No, more than that. That's 21 squared, is 441. What's 22 squared?
484.
484 minus 4 times -1 over twice a. So that's 22 plus or minus the square root of 488, because -4 times -1 is +4 over 2. And then you actually got it, because you have to solve algebraically, you got to actually do the simplifying of this radical right here. 488 is, got a 2 in it at least, and that's 244, 122, 61. I think 61 is prime. So it's going to be 292 plus or minus 2 root 122 over 2, and there's a 2 in everything, which is 11 plus or minus root 122. Okay, so far? Now you gotta find x. We log both sides, we get x equals the natural log of, what's the square root of 122? A little bit more than 11, isn't it?
Yeah.
Then 11 minus a bit more than 11 is going to be negative, which you can't log. So the only thing you have to log is 11 plus the square root of 122. Because the -1 gives you something where you're logging a negative, yes?
What if for, like, when we're doing the work, like, for the quadratic equation, if we sub, like, a different variable in for e to the x?
If you solve for something
No,
other than,
like, on the, like, behind you. If we sub the, like, a different variable in for e to the x,
Like a
so
2.
it's easier to see,
like a 2,
or like, y is e to the x.
so that you have y squared minus 22, y minus 1?
Yeah.
And then up here you solve for y? That's fine, but you got to come back to the e to the x eventually. You got to come back to this.
Is that fine for the work, though?
Sure, sure. If you tell me just out to the side, if you just say let e to the x equal y, I'm fine with that for the rest of the time. But you got to come back to this point. It's not somewhere to find what this is. Okay with that? I understand you don't want to drag an e to the x around. It looks weird. It's hard to deal with. It's bizarre. That's fine. You can make a substitution. That's great. But you got to come back to it eventually. Okay, we all clear on that one? That one's pretty intense as far as the algebra and stuff goes. A lot of work.
On that one, you only get one right answer, right? Because 11 minus the square root of 122.
It's negative, which you can't roll. That doesn't mean you'll only get one on this. It just happened to be the one that I made up happened that way. Okay. If 11 minus that radical is still positive, you got to find a both. Okay. Next one says, solve the equation. That's a logarithmic one. Algebraically. Again, you got to show your work. Then you have to list any extraneous solutions and explain. If there are no extraneous solutions, explain why not. we gotta solve a log equation. Let's say one like this. I have no idea if this is gonna come up with extraneous ones or not, but I'll show you how to answer both. It says, for example, let's do the log of, I'll do a natural log. Natural log of 5x minus 2/3 the natural log of 3x plus 12, no, 11 equals 0. Let's solve that thing for x algebraically. What's your first move? Condense the logs. If you don't know that's your first move, you haven't got a prayer getting this one right algebraically. You've got to get any logs. If there's more than one log, you've got to get them all the logs on one side and then condense them together. In that case, it would be the natural log of 5x over 3x plus 11. I'm going to change this to 1/3 because it's going to be easier. To the 1/3. Nope. Yep. Everybody clear on that? That's your first move. And if you can't make your first move, it's going to be tough. You're not going to be able to get it right. Not algebraically anyway, which is what's required. So get them together first. And then
Oh, do you both sides?
you eat it. Correct. You get that logarithm gone now that it's a single log. You have to change that log to an exponent.
Then it just like gets rid of it. It's 0.
Yeah, that's why it's nice that it's equal to 0. And it is on the test too. But at this point right here, you eat it, or in other words, you change it to an exponent, which would be e to the 0 equals this mess, which turns out to be not so messy pretty well, reasonably quickly. E to the 0 is 1. So that if you understand that that's 1, you can write it 1 over 1 across multiply, you get 3x plus 11 to the 1/3 equals 5x. Everybody okay with that so far? And that's the algebra after you eat it. How are you going to get that cube root off of there?
Cube both sides.
Cube it. Yeah, that's the inverse. So we cube this side, we cube this side, and we get 3x plus 11 equals 125 x cubed. If you can get it that far, I'll let you polyroot find the answers. It would be 0 equals 125 x cubed minus 3x minus 11. And don't forget that your x squared is missing and you got to put a 0 in for its coefficient when you polyroot find it. So if you can get it to there, you can use your electronics to find the rest of it. I won't make you quadratic form. Well, you can't quadratic formula that because it's a cube. And even if you could, even if this ended up being quadratic here, you can use the polyroot finder at that point. This shows me, you know, how to condense logs, change them to exponents, deal with the algebra a little ways through, and then you can use the electrics to get it. But I need somebody to find the solutions because we've got to find out if they're extraneous.
0.46.
Pardon?
0.46. But it has some imaginary ones.
So 0.46 and that was it. The other two are imaginary.
Yeah.
Okay. So we got our 0.46 and that may or may not go on the blank depending on whether it's extraneous or not. How do we decide that?
You plug it in for x.
You plug it into the original. Nothing else along the way will do. It must be the original.
Oh,
5 times 0.46 is still positive. We're good. 3 times 0.46 plus 11 is still positive. We'll keep it. So this is what you write, folks. In the blank for this, you write x equals 0.46. And then down here it says explain. So you have to explain whether there is one or not. And you would say 0.46 is not extraneous because it doesn't make me log a negative in the original. That's the words you write. 0.46 is not extraneous. Because, and you can write it a little better, not it, but plugging it in, and plugging is okay. The original, and it has to say the original because I don't know where you plugged it in. Did not make me, you can actually do that if you want, log negative. If there was an extraneous, just pretend with me. Just pretend that you got down here and you got three solutions, and one of them was 1.23, and the other one was negative, I don't know, 2.1. You would write all three and cross that one out. The 1.23 won't make you log in to get a negative either. But the negative 0.21 does right here. And so you would say, negative 2.1 is extraneous because it made me log a negative in the original equation. That's all you need to say. It says explain the extraneous ones, or if there aren't any, explain why not. You see what I'm saying? So you explain the one you crossed out. That's what you have to say. Negative 2.1 is extraneous because plugging it in the original equation made me log a negative. Or caused me to log a negative. You can say us if you want. Use the royal we if you want. All right. Do you see how that one's going to go and how you explain it?
Yeah.
Okay. I know it's not very mathematical, but that's exactly how you decide if it's extraneous or not, by plugging it in the original and see if it makes you log a negative. Okay, number 12. This is your only one dealing with logistic. And what's really cool about it is they give you the equation. They give you the logistic equation. They make you come up with it or regress it or anything like that. And here's what it says. And it talks about rabbits. How poignant about the rabbit busting on 84. The population of rabbits in Mar Vista after T months is modeled by, and it gives you a logistic function. And these are your questions. What is the population at T equals 0? What do you do?
That would be like a number on the bottom.
Not exactly. You let T equal 0.
Oh, yeah.
Find out what the number is. Okay? Does that make sense to you? It says, what's the population at T equals 0? So you plug T equals 0. You let T be 0 and figure out what it is. I'll show you in a minute if you want. B says, this one's tricky. B says, when will the population reach a certain amount? Does not say you have to do this algebraically. And thank goodness. Because you can graph this one. You graph the population function and you graph the horizontal line, 1500. That's a population, that's a Y value. And find the X value when they cross. And it's not a particular year. It's just a number of, and I think I told you as I read it. Mar Vista, T months. So don't put years on it and don't leave it blank. You need units. The T values are measured in months. Pay attention to that. And then C wants to know what's the significance of the constant, and it gives you a constant number that's fairly significant. You should know what it is. I'll tell you what it is. The significance of the constant, and they give you that constant happens to also be the numerator of your logistic function. What is the significance of that? What? It's the carrying capacity of the environment at Mar Vista. It means, what it really means is what you really should describe instead of just saying what it is as a vocabulary word that you learn. You should say, it's the maximum value, it's the maximum number of rabbits that are sustainable at Mar Vista. That's what it is. You following? Don't tell me it's the upper asymptote. That's just a mathematical explanation. I wanna know what it means in the terms of the rabbits. Y'all clear on that? Do you need to see how to do the other two? Do you need to see how to do A, where you let t equal 0 and find out what it is? Anybody see that?
We should do that on our calculator.
You can, but you have to be careful because the denominator is made up of more than one term. Make sure you use the fraction button or parentheses around your denominator somewhere, okay? And then when will the population reach a certain amount? That's where you graph the function, open your window up enough to see your horizontal line and find out the time value that goes with it by an intersect. You can solve it algebraically, you have the skills, but it's rough, can be. Everybody clear on what to do with that one? Yes, no? Okay, the last one. Well, there are 3 left. 2 of them are bonuses, and that's what I want to spend the rest of the hour talking to you about. Number 13 is required, and I haven't taught you how to do it yet, and you're being tested on it tomorrow. Because I didn't have time when I left on Wednesday before the bell rang to teach you the little bit about section 3.6, I think it was. So we need to talk about that for a few minutes, okay? You'll know how to do it when we're done here. But I need to teach you a few things and also show you the formulas and how to use them for the bonus. And if you decide to do and study for the bonus, you may not have any sort of a cheat sheet. You have to memorize the formulas, and you have to memorize what each piece of it means. And it can be kind of tough. That's why I made a bonus. So let me teach you what's required first. And then we will, I'll show you how to do the bonuses. This is going to be your saving grace on this problem. The amount of money in an account, that last section's on exponential finance. So this is, and you've seen this before, but I'm going to re-show you how to use it. Is equal to the principal investment times 1 plus R over N to the NT. Yes, you have to have that memorized. You have to know what it is and how to use it. This is the amount of money in your account after a certain amount of time. This is continually getting bigger. This is an investment. Okay, this gets bigger all the time. This is what you initially brought to the bank to put in this CD or whatever it is you're investing. This is the interest rate, always written as a decimal. If your interest rate is 2.4%, you're going to put 0.024 there. The annual interest rate goes here. T is always in years. When you're doing finance, T is always annual. T is time in years. N goes in 2 places, and it is the number of times you will be compounded per year. So if I give you a statement like this, this is just a straightforward find the amount. Find the amount in your account with a $1,000 investment at 2.8% compounded monthly for 10 years. This is what you do. It's the 1,000 principal, 1 plus 0.028 divided by 12, because there are 12 months, to the 12 times 10. That's how many times they'll compound your money over the lifetime of the CD. 120 times they'll compound you. 12 times a year. That's why they have to take the annual interest rate, split it up into 12 pieces. Because they're going to pay you a 12th of that annual rate every month when they compound you. You understand where everything came from?
Yeah.
All right, great. Now, let me give, I assume you can crank that out.
And
Okay.
this is question 13.
Well, this is like unto it.
Okay.
All I'm saying is that if they wanted to know what A was, this is how you would do it, and they would give you all this stuff. But perhaps they'll say something like this. Just thinking about this. If you're going shopping for a certain CD, or perhaps investing in mutual funds or bonds or whatever, and you're shopping for a particular rate because you just inherited let's say your parents, they're worried about you going to college, and let's say your parents just inherited $5,000 and they need to turn that into $10,000 by the time you get out of high school and you're a freshman. What rate should they hunt for compounding quarterly? That's rough. That one would be something like this. You have 15,000 No, did I say 15 or 10? 10,000? 10,000 is what I wanted to grow to. Having 5,000 to invest. Do you understand what I'm doing? Times 1 plus R, we don't know. We're going to compound quarterly, and we've got to get this done in 4 years. That will help us shop for a particular rate to invest with. If we want to, if this has to be done by the time you head off to college. Do you understand the scenario? And R is to be solved for. First thing we do, isolate the exponent by dividing by 5,000. So this will be 2 equals 1 plus R over 4 to the 16. This is a really weird solving. This one's strange. How do we get at that R in there? You got to get rid of the 16. How do you get rid of the 16 when it's an exponent? Use 16th root. It's crazy. I'm going to 16th root both sides. Did you catch that? Weird. Then we take that number. It's just a number. I don't expect you to find it yet. We're still manipulating things. It's going to be the 16th root of 2. Lop that off. Minus 1 equals R over 4. And so it will be whatever this number is times 4. Because you're going to cross multiply. Do you see that? That takes care of this. Then you crank that out. Do you know how to take the 16th root of 2?
Yeah.
You can either go find that thing in your catalog or wherever it is in the calculator. I don't ever use it. I just take 2 to the 1/16th. 2 to the 1/16th minus 1, whatever that is, times 4, written as a percentage.
$17.7%.
Yep, that sounds about right. So you look at that, you solve that, you go, all right, you're the husband talking to your wife. All right, dear, we're not going to get that. We've got to lower our goal because nobody's going to pay us 17.7% for only 4 years. And if they do, it's extremely risky, and you might lose. You're very likely to lose your 5,000 instead of make it grow. And so that's the kind of thing you do. You go, I got 5,000. I got to turn 10,000 in 4 years. If I can find a quarterly compounding interest, what rate have I got to get? And then you look at that and go, okay, got to lower our goals. But that's how you go out finding R, okay? Now, what if instead you wanted to take that $5,000 and double it? So we're right back where we were. And you want to know how long it's going to take to double at we'll say 5.5% compounded semi-annually. How long will it take? You guys following all this? You see where I'm plugging all this in? I'm making it up as I go and filling in the details.
Yeah.
We want to know how long it will take to double. So first thing we do is divide. There's your doubling right there. How are we going to get at that t? How do you get at any exponent?
Log.
You log it. You could do log base too, although that would be buying trouble in my opinion. I would use one of the keys you already have in the calculator. Do you want to use common log or natural log?
Natural.
All right. Then I would natural log this side. It doesn't matter, by the way. Choose either one. Equals 2t natural log of this, whatever it is. The only reason I'm not writing a number down here instead of writing this plus around is because I don't have a calculator in my hand. Like that. Then how do you solve for t?
I have a question. So why could we not go log base 1 plus 0.055 over 2 square root of 2? Like put the log base, then put the inside parentheses at the bottom.
Here?
Yeah.
Why can't you log the inside?
No, like it's like log base, the parentheses,
Oh, you could.
then 2.
You're probably in lots of trouble if you ask me.
Like,
It's just me.
why would that not be good?
The log base this mess here?
Yeah.
Go ahead. I'm not doing it. I'm not doing that way. Let's pretend you did it my way and got to here. Now how would you solve for T? You divide by both of these guys. T is times by 2, it's also times by that log. Grab your calculator and carefully work through your fractions. I think if you put it in there just like that, you grab your fraction button, put that at the top, it will have parentheses on it like that, make sure you close it. And then go to the bottom and put it in just like that. I'll tell you how long it'll take to double. At 5.5% compounded semi-annual. The only thing we haven't solved for in this, we've solved for R, we haven't solved for N. You're not gonna have to solve for N. Okay, and we haven't solved for P, but it tells you in the problem what the principal investment is. So if you can solve, if in a scenario, if you can take this and solve it for R or solve it for T, it'll be one of those, and you'll be all set.
12.7.
What'd you get?
12.77.
Okay.
Or 78.
Somewhere in the 12th year after investing, you'll double your money. Okay? After that, it will take not far less, but it'll take quite a bit less time to double it after that. It's the exponential growth. It's kind of cool after you get to be my age if you invested when you were young, which I did. It's fun to watch it grow. In 20 days, just before the election, my investment grew $8,000 in 20 days because the election was. And then right after the election, it grew a little bit more, although it dropped a little bit today. I haven't figured out why the markets dropped today, if they did. Anyway, right after the election, it grew another quite a bit because investors love sure things that are very definitively decided, which it was, the election. They don't like that. Even if someone is elected isn't really nice to the markets. It's a definite choice that people made, and it's not iffy, and there's no chance of volatility and that kind of stuff, or recounts on votes and stuff like that. Investments go up, kind of nice. Been good for my little investment. All right. Now I want to talk to you about 14 and 15. Is anybody interested in those? Anybody interested in those bonus points?
Yeah.
Okay. I'll tell you where the equations are. You need to get them memorized, and I'll even show you how to work them, use them to work through something. This has to do with the idea that most people when they invest, including me, do not walk into the bank with a large sum of money and say, here, take my money, use it how you like, and pay me for it. Most people don't have that kind of cash. What most people do is they put $50 in a month or $200 in a month, and they just keep contributing to the principal and let them invest it. That's a different problem because it's not nice and steady and even like this. I do require you to know how to do this. This other one is not a requirement. It's a bonus. If you can do it, that's great. We're going to talk about what's called a growth annuity for saving money, and also to figure out how to make payments if you're going to borrow money, what your payment per month will be. Like if you're looking for a mortgage or you're borrowing money to buy a car or something like that, you have to make monthly payments. All right, so this is in 4.3.6. We're talking about the stuff that's on page 302 and page 303. And the formulas for both directions, whether you're going to save money by putting a little bit more into the principal every month, or whether you're going to borrow a loan, this is their names. There's the future value of an annuity, means what your money's going to grow to. And the other one's called the present value of the annuity, what you're going to borrow and what you're going to have to pay with all the interest and junk that goes with it. So let's look at a future value for annuities. Page 302, or Sam, it's the It's about 4 pages in. You'll see it says annuities future value in the middle of the page somewhere.
Okay.
All right, so here's the scenario. Let's do example 8. And then I'll show you what each of the, well, I'm gonna put it up here so I can point to them. Read it to me. I don't have this memorized. I just look it up in here when I need it. So future value, that is a single variable. That is not F times V, is equal to R, right? Times some fraction. And R is, no, it's 1 plus I to the N minus 1 over I. 1 plus I to the N minus 1 over I. Notice there's no R, well, there's a capital R, but that's not the interest rate. Let's see if we can understand what each of these things is. It says in example 8, as we do this, I'll point out, it says at the end of each quarter year, Emily makes a $500 payment into the Langham Mutual Fund. R is that investment. That's what you're putting in periodically. In this case, every quarter, every 3 months. Okay, so that quarter was an important thing too. So this is your investment. Well, sorry, this is what you're putting in every period of whatever's going on. So this, in this case, would be the 500. She's putting $500 in every quarter. All right, and it says, if her investment earns 7.88% annual, that's very important, annual interest rate compounded quarterly, what will be the value of Emily's annuity in 20 years? Okay, this is all very convoluted, folks. You got to take that 7.88. And you've got to divide it by however many times you're going to compound or however many times you're going to put money into the bank. And that is I. So if you're going to put money in monthly, then it would be your annual interest rate divided by 12. That is I. Okay? And N is the number of times they will pay you over the life of the investment. Now she's going to invest for 20 years. 4 times a year is 80 payments. So N is equal to the time in years. I better write it this way. Is equal, I'll just write it like this, is equal to the years times the number of times a year you're going to invest. So in this case, 4. I'll just do it with numbers. It's 20 years times 4 times a year. There will be 80 payments. So N is the number of payments in total number. Okay. So up here I have 1. I'm gonna so that you don't struggle too much with a whole bunch of stuff to put in and make an error. I'm gonna type 1. I'm gonna find out in my calculator 1 plus this and write it down here as a number. So 1 as a 0.0788 divided by 4 equals, now I'm going to add 1 to that. So this is 1.0197 raised to the 80th minus 1 over, not that 1.1097, but 0.0197. Follow that? This thing that sits at, when we crank all that out of there, or whatever sits over here, that's going to be how much money you'll have in your account after that investment of 20 years. So start cranking that out. I got the 1 raised to the 80 minus 1 divided by 0.0197 times do we have a number?
$95,483.
Yep. How much did she actually invest overall?
How she invests.
No, how much total money of hers did she put in the bank? How much total money did she invest over the lifetime of this investment?
500 times 80.
No, it's 500 times what? Oh, yes, it is 500 times 80. Yes, what is that?
40,000.
40,000. So she put 40,000 of her own chunk of change in there and almost doubled it. She was at 95, well, more than doubled it. 95,000 is what her investment is. 500 every 3 months. Okay. Do you think you know what I and N and those things are and how to figure them? Make sure you commit this to memory if you're gonna do it. Now let's do a loan. Okay, and this one is present value. We call it that because it's all based on the amount of money that you're taking away from someone else to go spend, and then you gotta pay it back. And it is R. What do you suppose R is in this case?
How much money they're giving you?
No. It's this is how much money they're giving you. This is your monthly payment. That's why this one's quite a bit different and kind of weird than the other one. Because the other one, we just found out the values if we were careful and plunked things in. That's a negative N, don't memorize that wrong. But this time, what the most burning question is to people is, if I borrow 280,000 to buy this house for 30 years, what will my monthly payment be? They want to know this number. This is your monthly payment. Just like it was over here. But you know how much you've got to put in every quarter. Here they want to know, what am I going to have to pay to borrow this amount of money? Okay, so look at this one. Carlos purchases a pickup for $18,500. What are the monthly payments for a 4-year loan with a $2,000 down payment if the annual interest rate is 2.9%? Let's see if we can plug these things in here. First of all, he's only financing $16,500. Do you understand that down payment thing? He's only financing $16,500. He had $2,000 to put down. So this is $16,500. You understand where I got that? Okay. He wants to know this. 1 minus 1 plus I is not the annual interest rate. In our case here, because he's doing monthly payments, it is the annual interest rate divided by 12. So I, over here, if you want to do this on the side, is 0.029 divided by 12. How many payments will he have to make? That's what N is. How many payments is he gonna have to make over the terms of this loan? That's how many. He's got a 4-year loan. He has to pay 12 times a year. That's negative 48 up here. Over 0.029 over 12. Again, I wrote this really complicatedly because I didn't have a calculator in my hand. But that's what you got to figure. And here's what happens, folks. You got to find this number and divide it into that. What's his monthly payment? Everybody get it done yet? I'll let you keep working.
Is it 364.49?
Get it to the nearest penny. 364.49 a month. For a $16,000 truck. You'll be jumping into the fine world of finance here pretty soon. It's gonna kill you. For a little while. I think it's awfully hard for people your age to survive in this economy. I got two of them, they're just a little older than you and they're dying. They get choked over. Okay, so you've seen an example of each. If you want to memorize them and make sure you memorize what each one of the ones stands for, then those are offered as bonus points. One's a future value, one's a present value. The two bonus questions. If you want to practice them, I have some. Over there in the 48 to 55, right in there, in that area of the exercises, there's some more for you to practice with. I would, if you intend to get these bonus points, I would practice them until you can do them without the formula in front of you and with just the words that are written, and that's all, because that's all you get on the test. When you can do it top to bottom and get them right, then you'll know you'll be able to get the bonus points. Good shot at them. Okay? If you want to do them. But you do have one of those previous ones I had on here that's required, number 13. Are you guys late lunch this week? Okay. Yeah, we'll do well. Guys get along with my substitute, okay?
Yeah.
Good. She had nothing but good to say about you, so I'm proud of you. That's good. All right, I'm gonna stop the recording, but I'll stay with you until the end. Until these guys leave.